Hi, I'm Les Kirkup. Welcome to this video on experimental methods for science and engineering students. This and other videos delve into the practices and methods that scientists and engineers adopt when they do experiments, and which are applicable when you yourself carry out experiments. The origin of scientific discoveries and inventions are to be found in the notebooks that are kept by scientists and engineers. In this video, we'll consider how scientists and engineers use their notebooks to document their work. For a better insight, we'll consider the entries in one particular notebook. Let's begin by examining the lab notebook entries of several prominent experimenters whose work led to groundbreaking discoveries and inventions. This is a page from X-ray crystallographer Rosalind Franklin's notebook. Franklin's X-ray work made a decisive contribution to the determination of the structure of DNA. Some of Marie Curie's work on radioactivity is recorded on these pages of her notebook. She was awarded Nobel Prizes for this work in 1903 and again in 1911. These entries from William Shockley's notebook were recorded while he was working at Bell Laboratories in the US. The entries relate to the invention of the transistor, for which Shockley shared the Nobel Prize for Physics in 1956. There is often a sense of anticipation, excitement even, when an experiment is underway, particularly during the data gathering stage. It is tempting to think, I'll just get on with the experiment and write relevant details down later. When later comes around, we may wonder exactly what was done. If little or no record is made as the experiment proceeds, we are forced to rely on our memory. As many things happen and are responded to during an experiment, vital details, which only reveal themselves as vital sometime later, may have been forgotten. The lab notebook is the place to record details of the experiment. Thoughts and ideas which occur as an experiment proceeds, and which may lead to other experiments, are documented in the notebook. It is also important to include things that didn't go to plan. For example, perhaps an instrument failed during the experiment, or that could be improved upon. When the experiment and its findings are to be communicated to others, key features of the experiment, including the aim, method used, data and preliminary analysis, appear in the notebook. These form the foundation of a report or perhaps an oral presentation of the experiment. Paper-based laboratory notebooks remain popular, though an increasing number of scientists and engineers use electronic laboratory notebooks, or ELNs for short. The purpose of both types is the same, to hold a contemporary and faithful record of all aspects of an experiment. Which type you might use is determined by the circumstances. Those working for a large company may be required to use an ELN, so that, for example, data can be easily archived, searched and shared between members of a team. By contrast, for someone working alone on a project at college or university, it is a paper lab notebook that may be more convenient, cheaper and easier to use. It's time to examine pages from a lab notebook and to draw out some of the main features. The pages we're going to look at are from 2016 and are taken from my laboratory notebook. The experiment described was intended to determine the power output and the efficiency of an amorphous silicon solar cell. So let's look at some of the features in my notebook. First of all, the date. Crucial to put that in so I can link this to other work that's been done. A brief title, so I can come back to it and know really what I was trying to do. Here is the aim or the purpose. Next is the equipment I used. The solar cell was supplied by a company, and here's the details. This is the solar cell part number, and there's some details about the solar cell, its dimensions here, 14 by 14. I've also mentioned that I used the contact infrared thermometer, non-contact thermometer, and a power meter. I'm given some details about the power meter here, which I've recorded, and I will come back to that when I need it when I'm writing the report. Next is the setup. There's a very basic sketch here That's all you need to remind you of the setup. And I'm saying here that I used a retort stand and a clamp to position the solar cell. Useful to write that down so I know what I would need if I want to do this again. Here's the circuit. It's a load resistor that's connected to the solar cell. And here's a voltmeter here to measure the voltage across the cell. Some details about when the experiment started and where it was located. So we've got basically some information about the time and the place. There's a measurement here of how much power is hitting per unit area on the solar cells. Again, vital information that I need to come back to later if I want to calculate the efficiency of the solar cell. There's a bit here about the weather at the time, which is important because I was outside. So there's weather conditions. Next comes the method. The method was quite short, simply to change the resistance, the load resistance, from 1 ohm to 5,000 ohm, and to measure the voltage across the load. Next we see some of the raw data here, which is the voltage across the load and the load value itself. So this, if you like, is the raw data in a column form, and I've included the units, resistance in ohms, and voltage in volts. Here, the next column is the power. Now, I've calculated that, but I haven't said in my notebook how I did that, which is really not good enough. So I should say here that the power was calculated by taking the square of the voltage and dividing it by the resistance. Also, if you look at this table carefully, and it's actually highlighted here, the maximum power is shown here. Now, what would have probably been better would have been for me to plot a graph of the power delivered to the load against the load resistance. And I would have got something like this probably, where there's a maximum, by the looks of things, at 50 ohms. And at 50 ohms, the actual power was 0.725 watts. At the end of the experiment, which ended at 11:40 a.m., the temperature of the solar cell was 30 degrees. Now I've written here a question. How has the temperature rise affected the output power, if at all? Now, I didn't control the temperature, and it's possible it did affect the power out, but I can't know that from this experiment. So this is a very useful comment that I can come back to later, and it might lead to another experiment. And certainly for me to go and look and see what other workers have found out about the effect of temperature on solar cells. Next comes some calculations. The area of the solar cell, the incident power is 23.8 watts. You have to take into account the power per unit area and the area. And then the maximum output we've got from the table here is 0.725 watts. So the efficiency turns out to be 3%. So I've done some brief calculations here, which are useful. I would probably check them later, double check them. But 3% is the efficiency. Now this bothered me at the time because I'd read somewhere that the efficiency of amorphous silicon solar cells in full sun, which is what it was at the time, it should be about 7%. So I'm asking myself to check this. Was I right? Should it be more than 3% and closer to 7%? This needs to be examined again. Finally, I have some mention here about doing uncertainty calculations here. The efficiency that I got is 3%, so my efficiency turned out to be 3%. But really I need to say plus or minus something, and I haven't done that. And I need to go back and calculate the efficiency, which will require me to look at the uncertainty in the incident power and that in the maximum power. I think that's a good place to stop. In this video we've explored these laboratory notebooks. I'd like to end by highlighting a couple of aspects of note-taking. It's hard to overstate the importance of making a record of an experiment as the experiment unfolds, even though the temptation may be to delay making notes until some time later. While it's fairly obvious that such things as the method used and the data gathered should be recorded, it is also important to record thoughts and ideas that occur as an experiment proceeds. These could be useful when it's time to communicate the experiment to others, perhaps in the form of a report. The ideas could also inspire another experiment. In another video, we will consider the characteristics of data gathered during an experiment. Until then, goodbye for now.